Hey yo, another day, another video. Welcome everyone. How you doing? I hope you're doing good. So everything is good. The stream is going well. As usual, this is Code Draw, and today we're gonna solve some lead code problem. Uh, Honestly, yesterday we didn't stream because I was a little bit sick, but I think today we're gonna do some good job. Uh, so don't forget to follow me on my social media account. This is my GitHub, and you can find my social media account in the bio. This is my LinkedIn. This is my Instagram, and we recently opened up a Discord server, so we can talk with each other. We can connect with each other properly. So without further ado, today lead code problems are the binary tree DFS. The previous stream we did those three lead code problems, and we're going to try to solve those three in this stream. So the theme of today is like the theme of the previous video. We have the problem path sum 3, which is a search for path filled with magical energy to restore the forest life force. And the second problem is the lowest common ancestor of binary tree, which is its theme is to seek advice from the ancient forest spirit who bridges all paths. So without further ado, let's delete this and let's delete that, and let's go to the problem. So this is the channel. Thank you everyone. Today we are 500 followers or 500 subscribers. I'm really grateful for that. I'm really thankful for your help, for your support. Thank you everyone, and let's go. Hello, hey, welcome stream, man. So we're gonna start with this lead code problem. Let's bring that. Okay, so. So here you have given the root of binary tree and an integer target sum, return the number of paths where the sum of the value along with the path equal target sum. The path does not need to start or end at the root or a leaf, but it must go downwards, traveling only from parent node to... okay, so we have two. We have the target sum, we have the binary tree, and we have the target sum, which is a random number. So let's see so the target sum here is 8, output 3, the path that sum. Okay, so this is it. Okay, so I think this is clear. We have this binary tree. We have this binary tree, and we will try to usually when we sum a or when we iterate through a binary tree, mate, I have a doubt. Can you get a software developer job without CS degree? Yeah, I think you can. Yeah, I hear a lot of people say it, but you have to be like extra, like I said, like you have to be more or better than one who have a CS degree. The CS degree will facilitate the job, but it is impossible to get without a software degree, without a CS degree. So work on yourself, grind lead codes, do some good project that solve real life problem, and keep the rest for the luck, you know. But I hear a lot of people that work as software developer without a CS degree. So usually when we iterate through a binary tree, we sum from the root, so we have only one start, and then sum from it to the leaves. But here in the problem, we have you can sum from any node you like. So this node, the sum of it is 8, which is the target sum. This node, so this is 1, this is 2, and this is 3. So we're gonna iterate through a binary tree like we iterate normally, like with the recursive function. And for every iteration we're gonna sum, or we have to iterate through it. Okay, so let's write some pseudocode. Okay, so what we're gonna do, I think here, so here I'm gonna use the normal DFS recursive function. Let's write it together. So def DFS, and I'm gonna make it root. It will have the root. So self and root. If not root, then return as action, and if it's not, so DFS of root dot left and DFS of root dot right. Can you create a roadmap? There is actually a roadmap. There is a powerful website which is roadmap.sh. There is a lot of roadmap for a role-based roadmaps, or you can choose the skill-based roadmap. For example, if you want to learn React or any type of other technology, there are project ideas. If you want to be a backend software engineer or backend developer, this is a total roadmap, and for every part you can see free websites to visit it. So this is a really good website for roadmaps. Okay, so and then what you're gonna do? Okay, so I think I'm gonna set either initialize counter variable to count the sum, I think, like counter. I'm gonna initialize it to 0. Okay, so for every when it visit this, it has to check okay. But if the root is already sum, so I'm gonna I think I can create a list. No. Or I think I'm gonna use another recursive function. So okay, so every time it will add. So I'm gonna function that count the sum of the visited nodes. So I'm gonna make a def count, or count def sum now. Man, any other one? So def count, make it self, and from where they learned all these. Well, a little bit from school and by myself. Actually, there is a really good video for I don't remember his name, but the title is 15 lead code patterns. So for lead code, you can check it. It's a really good video about lead code patterns, and yeah. So besides the root, okay, so for every okay, let's return back to the one. Okay, so let's delete all of that. Let's change the color. Okay, so how are we gonna do it? If it is going from here, okay, so it's gonna use this and this. Okay, so it's gonna store this number and store the number. So it's gonna store the root. It seems like it's not that easy. So okay, let's start from again. So this is 10. We're not gonna consider it, aren't we? So the bed does not need to start from but must. Okay, we have to consider it. Then there is. This is the DFS right, and this left, and this is the DFS right. So the DFS right has to store the 5. Okay. No. So for every DFS has to. Okay. So for every DFS, there is a function that's gonna count with it. So let's say count. I'm gonna make counter. What we're gonna do as a parameter. So if we have 10, then we're gonna store 10. But okay, so let's try something. Okay, so self count and root. So counter plus equal root dot val, and then if counter equal target sum equal target sum, then we're gonna just we have another variable which is the output. So if target sum counter variable and the return variable, so final equals 0. Okay, so So final plus equal 1, and we have to set the counter to 0 again, I think. And now for every DFS we count of root. I think we're good. Okay, so let's just test it. We have to return, so return final. So the output is 0, and the output is 0. Okay, I'm gonna test this. So I'm gonna print I'm gonna print root to check if the DFS is working or not. What? Oh, I didn't. Okay, so here we have to DFS of root. Self. Okay, so self. No. Self the root. Okay. So how am I gonna do it? So I think here it's self. Okay, I'm just gonna check this problem to make sure that the DFS is, if not root. Okay, so self dot max depth. Okay. Not root dot left, self dot DFS. Okay, self dot DFS and then self dot DFS. Okay, so here it's self.dfs, then it's self.dfs, and here it's self.dfs also. Okay, so what is going on? I have to make it in a number is required, not root. Is it also self? Okay. Count. So I want to change this. So this like count 1. I'm gonna make it count 1. So don't let him. Okay, so count 1. It's not defined. like, okay, so self counter. So I'm gonna initialize it here. Okay, so counter, and here self dot counter equal counter plus and here so DFS, and then the DFS I'm gonna do it's there again, so cannot access on honeypot, it's not allocated. So self counter. Okay, so count one, missing one, required position on outside. Okay, I'm gonna make it 0 here. Not 0. Okay, so what is it? No, the like I have to pass it the target sum. So man, the functions. Gonna make it like that. So def here count and the target sum. Okay, so here if counter equal target sum. Okay, I'm gonna target sum. Yes, and here target sum. So target sum is not defined. I have to pass it also here. Okay. So target sum root and target sum. Okay. So target sum and then target sum. I think we're doing too much. Root has not. Okay, seriously, I'm gonna just ask chat to just correct the syntax. So, okay. Okay, so self.final, self.dfs, counter. So I'm gonna see what are the difference between my solution and his. So here he initialized the self final and the self DFS and then return self final. Okay, so in the DFS, if not root, self final, okay. And if it's not, so self count, counter is gonna run perform, if count, and then self count, counter, okay, so this is good, right? This looks right. Oh, it's correct. I think he didn't correct the logic. The logic is good. It's pretty good actually. The logic. Just the syntax. So I think we're good here. Okay, we're good, but the runtime is crazy. The runtime is very, very low. So let's just check other solutions. Set of number path, space OL. Okay. 0 DFS. So they've tested this the DFS and another. It's like mine. Like it's pretty much my solution. But why the runtime is okay. It's not that bad. It's not that bad. Oh, this is in Java, so he used the hash map and the recursive. Okay. So the first LeetCode problem is good. We did it in a good way. Let's go to the next one. So the next one is this. Oh, okay. So this is it. We're not gonna work on this today because I think this is a binary tree BFS. It's not DFS. I hope this is a DFS because I'm really not revising the BFS, so I hope this is a DFS. Not that, and this is it. Okay. So, given a binary tree, find the lowest common ancestor LCA of two given nodes in the tree. So, according to the definition of LCA on Wikipedia, the lowest common ancestor is defined between two nodes P and Q as the lowest node in T that has both P and Q as descendant, where we allow node to be a descent of itself. Okay, so we have this. We have P and Q. Oh, so he's gonna input P. So P is 5 and Q is 1. Output 3. So then it's 3. Oh, this is it. So it's 3. And here we have 5 and 4. 5 and 4. So the output is 5. Okay, since a node can be descendant of itself according so the lowest common, so we're gonna look for the common node and we'll search for the lowest common one. Okay, so it is said here in graph theory and computer science, the lowest common ancestor is called least common of two nodes V and W. Trade direct acyclic graph. T is the lowest. Okay, so this is the ancestor. This is the common, and this is the this is the common, or this, or like this is the common one, the least common one, or the lowest common one. So the lowest common ancestor. Okay, so this. Okay, okay. So let's focus on this. Let's put that away and let's make another report. Okay, so so let's focus on this test case. So in this test case, we have 4 and 5 as inputs. So we're gonna make it up and then make it up, and we'll observe that the 5 is the lowest common ancestor. So can we make it like the normal DFS from the ancestor to the children, or from the parent to the leaf? Can we make it like this? Like, okay, so we're gonna go like this. If we find the input, or like store it. Can we store it? So what is the idea behind this? So I think the idea, okay, let's red on this. Okay, the idea itself, I only have one thought. So we're gonna begin with defining the DFS recursive as usual. Okay, that's okay. And then condition if root.val equal one of the inputs. There cannot be the two inputs, so equal input 1. Let's start input 1 or input 2. What you're gonna do? Well, I don't. Can we make it up again? So, okay. Like we go up to down and then return down to up. Can I make it like this? So give me the second test case. I think I'm gonna need it also. Okay, so we have this and we have that. Okay, so this is our two test case. So this is the 5 and the 1 have this as ancestor, the lowest one. No, we can't. We have only two options, right and left. So okay, I think if root dot right and root dot, okay, if root dot right equal one of the input and the root dot left equal the other one, so it's the ancestor. Okay, so okay, if root, so we're gonna check for the children. So now we're gonna put it. So if root dot is the first input is the right and the second is the left, or it is so P and Q. So I'm gonna assume that P dot dot left is Q and root dot right equal P. We're gonna return val, return root dot val. Okay. Then, but if this is not the case, if we have 5 and like 0, okay, what are we gonna stop? Okay, I think if we find one of the input, then the DFS should stop at this. So now, oh no, it's gonna go up to here, down to here. So we're not gonna stop. So it will keep searching. What does he do? So welcome stream. I'm currently doing some lead code problems. So this problem is the lowest common ancestor of a binary tree. So now we are about to brainstorm the problem and then we're gonna code it. Welcome stream, by the way. Do you play Fortnite? No, I don't play. Unfortunately, I don't play it. Well, I play chess, if you want. I played also some Valorant. I play also some Valorant and Rocket League, but Fortnite I have never played it. Okay. Really can't. Hey, thank you, man. Welcome stream. So it's about the 5 and the 1. Those are, and those, how we're gonna do it. So let's say if it's the 1, the 8. The 8 is the second output. So I'm gonna do it. I'm gonna do it. So this is the lowest. Do you think we have to store it like 3 and then like for every path we have to store? Okay, so this is 3, 5 and 2. Okay, and then we're gonna make another list which has 3, 1 and 8, and then we're gonna iterate through those two and see for the similar number. This is our root. Hey, hello, Kay. How you doing? How was your day? It's okay. So for every path, let's make this. For every path, we're gonna initialize. I think this is not the idea, but I don't know. Double day, why? It's good, it's good. So I'm solving the same question too. Very funny. Oh, really? Yeah, that's cool. So we're gonna initialize a list of the path, and then we iterate. Okay, so let's go step by step. We don't have to rush it. So I'm gonna define it here. Set. So dfs sub root if not root, then return and then dfs of .dfs of root dot left and some dfs root dot right. Okay, so now for everyone. So okay, why it is printing it like this? Okay, so root of var, okay, to get the what the hell? So okay, so I'm not gonna focus on this, but now, so we're gonna check for the children. Okay. So on the DFS, we're gonna check for the children. So if we have one root here. So if root.var, if self dot root.var. Okay, let's try equal key or root.var equal pay. Then what you're gonna do? No, I want to root.write.var, and so I'm gonna check for its children. Dot left dot, well, I don't know, it is okay. It is gonna be Q or P, and here Q or P. I'm assuming that if here it's Q, then the other will be P and reverse. Then we're simply gonna return the root.var. Okay, this is if n or root should be above print statement. Huh? If n, oh, if not root. Oh, okay. So okay. Like okay, this case for this, like if for this, so the 5 and 1 are the children of the root, then we're just simply gonna return it. Simply gonna return the root. I think that. Like there is 2 base condition. Okay. So for every path, I'm gonna do it. No, the root as well, because it's 3. Yeah, okay. It's not big of a deal. Yeah, it's not always correct, but like we can have this test case. For example, 5 and 4. So the 5 it's, but it is one test case. Like I'm thinking to store the path in a list and then check it, but I think this is not practical. But I don't know how to do it. If root equal P or no, not if the root equal Q or root equal P. First of all, it has to be the value of the root, not the root itself. And I think root. Oh, because already here we have. Yeah. We have. Oh. Should be 2. This. Okay. Let's see if. Okay. Equal P. Okay. So So if we say, let's say we are in this test case, so root, then we're gonna make the DFS left, and then we're gonna return. So this equal Q, and this equal P, this equal Q, and this equal P. Then we simply gonna return all of them are nodes, so you can equate them. I'm really not understanding you. Okay, sorry. Oh, like, okay, so this value will be 5 and this will be 1, but how we gonna return the 3? You had a good idea about putting their path in the list. You should try it out. Yeah, I'm gonna try it, but I don't know. So we how are you gonna do it? For every when we have to initialize the list. So the list here should be 3. Are we gonna make all the lists? So 318 and 308 0, and then no, the complexity will be on fire. So okay, let's say we have 3 and then another list which is 5. Okay, I'm gonna think of the list. So for the first test case, it's gonna be 3, 5, 6, and then or can I put them in one list? So like 3, then it will be 5, then it will be 1, like okay, then the 6, then the 2, then the 0, then the 8, and the 7, and then the 4. Okay, so we have 1 and 5. How we're gonna know the, let's suppose we'll have the 4 and the 7, 4 and the 2. How we're gonna know the, cannot know. What happened to coding in C++? So I'm not really good in writing in C++. I will try in the next in the upcoming video to write in C++ or in Java. I wrote some I did some videos coding in Java, but I'm not really good in it. So I'll try in the next video to code in Java, maybe. Welcome stream, by the way. So maybe the answer could be in traversal. Think that a good idea. Traversal. Man, I wanted it to be a normal DFS problem. Do you do advent of code problems? Currently no. But so like first another like okay I'm gonna so currently I'm not. How many times did you apply for a job? Not too many times. Like I can count them, but not many. Not many. Not too much because I'm really a student. I don't have the time, so I'm looking for an internship, and the internship period is gonna start on February or on January, and I'm applying from now, and yeah. So really, I didn't apply for that much. So like it's normal one. Hey, okay, I'm listening. No, it's too early to ask ChatGPT. No, it's too early. So level order 1, 2, 3, 4, 5, 6, 4, 5. Hmm. What if we have a stack of path? And then we keep popping until we find the same number. Stack of path, like you mean okay, so let's organize the thing. Okay, so you're saying we're gonna make a stack like this, and this will be like 3, 1, 8, and like 3, 1, 0, and 3, 5, 2, 4, and 3, 5, 2, 0, 3, 5, 2, 7, and 3, 5, 6. No. So how's the stack? Like in order, like in level. So it will be 3 and then 5, 1 and then 6, 2, 0, 8. I'm thinking of the level 1. So but the level is not DFS, so it's BFS actually. So it's a queue, yeah. And we're not gonna work with recursive, we're gonna work with while. Stack P318, stack P, stack Q. 2 stacks. Okay. So 318. and 3 5 2. Oh, it's a one stack but two element. 3 5. Yeah, this is it. So 3 5 2 4 and 3 1 8. Oh, two stack, two stack. Hmm. But how we're gonna why how we gonna stack the three? Why do we have to stack the three when we don't know, like, the stack idea is so good. The stack idea is so good. Are we just gonna stack numbers? The stack idea is so good. Okay, so let's say now we have this stack. We're gonna stack 3 and then no. How are we gonna stack it? 3 1 8. Can't we make it in a level? So 3 and here 5 1 and here 6 2 0 8 and then 7 4. Here we don't have our numbers. Here we have one of our number. So it will be this or this. If here we have the other number, if here we have the number, so it will be one of this, the ancestor. But how are we gonna, like, hey, do you see what I mean? I think it's a good idea. Like, I'm gonna draw it again. For every node, have a stack of the path, one element per level. For every node, we're gonna have a stack. Yeah, listen to me, listen. So, I'm gonna stack. I'm gonna stack every level in an element. So here we have 3, and here we have 5 1, and here we have 6 2 0 8, and here we have 7 4. So listen to me first. So here we don't have our number, so we're gonna pop it. Here we have the 8. Okay, we're gonna pop it also. If we have the 2 in this level, so this level is the lowest ancestor, but we're not gonna know it's the 5 or it's the 1. So okay, so I have a stack of Q and a stack of P. Hi, hey, welcome stream, man. It's a good idea, but you don't know. Yeah. What did you miss? Actually, we solved one lead code problem about the path sum 3, and now we're solving the lowest common ancestor of a binary tree. So we're about to solve it. So I didn't really understand your idea about the Q and the P stack. Okay. So something like this, and okay, so let's say we have Q and we have P. So we have 3 here. Where are we gonna put it? Okay, so let's not put the 3. Okay, let's put here 5. Go through the root to P and store all element in the stack. Which so so, so let's say the P or the Q is here. So where do I know where to stack 5? Is it in Q or in P? Or I'm gonna just stack them. So okay, so here I'm stacking the 5 and then the 2 and then the 4. Okay. Okay, so this is it. 4. Okay, let's say we have 4 4 and 5. So this is the 4. Let's assume you know the root. Let's assume you can calculate it and you can have the stack and then continue from there. Okay. Okay, we're gonna make some pseudocode. This is not it, this is not it, and this is it. So I'm gonna make a list. So stack Q equal and stack P equal for every one we're gonna make it in the stack Q and the stack P. I'm not getting it really, so I just want to all of this. Okay. So okay, let's say we have the Q and the P. We started from 3 and we have, let's say we have the 7 and the 5. So this is Q and this is P, okay? So 3. Then we're gonna go like this. What we're gonna store in Q, what we're gonna store in P? Or just store them like that? P will have 3 at the bottom and 5 at the top. Yeah, okay. So P, okay. And we're gonna check every time we push. Okay, so we push it here. But why we're pushing it in Q? Will have 3 at the bottom, then 5, then 2, and 7. Okay. Oh. 3. But how do like you're saying you know the path, but we don't really know the path. So why it's not 3, 5, 6? Okay, we're gonna deal with it later. Okay, so let's say, so this is the 7 at the top and this the 5. Then we have to see the common one, which is 3. Okay, that's good. The bottom element will be the lowest ancestor. No, it's not 3. It's 5. I'll read with DFS later, but so here will be 5. So I think the I think if we had an like if this element is Q, if we find here P, so the P will be the ancestor, and then if we have this P and here we have Q, so you pop the larger stack till you find equal element. Yeah, okay, that's cool. Okay. Okay, so we're gonna pop this until we find the 5, which is the lowest ancestor. Mm-hmm. Hmm. Okay, so let's try it. I think we can do it. So I think here we have to pass the stack Q and the stack P. We have to pass it. So like. Okay, now I found how to find. Now think about how you will use DFS to make stack iterate DFS, and if you have path, return the stack. Right. I'm just gonna stack the element and see. So I'm just gonna stack the element and see the result, and then I'm gonna get back. So, and here stack P. Okay. Here also I'm gonna define the 2 element, and here self dot stack equal. You've got the script correction. Hey, thank you, man. Welcome stream, by the way. Hey, thank you very much. So stack up equals stack up, and then we have to push to it. So do we push the root? Okay, so I'm gonna push to the 2 stack. So stack the q dot append root and stack p dot append root, and I think this we don't need this. We're just gonna run it and then okay, so okay, so everything is good. I'm just gonna print here the stack Q and the stack P to see what is going on. Can I make them into a list, or you will use the FS to calculate stack? Can I append dot val? Okay, I just want to ask you why this root doesn't have val. Do I have to write itself? Okay, so okay, for now you can write manual values of stack to see if you can code the second part. I'm really not getting it. Why? Okay, so uh, uh, it's because root could be none. Every time you write something about tree, you have to have a condition. If not, okay, okay, but some I cannot. So okay, so now we we have to iterate through the list which has the larger size. So if len of stack p, I'm gonna make it it's greater than len of stack q, then we're gonna iterate through the stack p, else iterate. Okay, so iterate through stack p, else what if they are equal? If they are equal, what we're gonna do? So okay, so let's say we have 3 5 3 5 and 3 1 1 5. No, it's not the equal. Like, okay, so every time we're gonna pop from it until we find the p or the q, and if we found them, so in this test case, if we have the 1 and the 5, so here will be 3 1. Oh, so we're gonna use this test case. Okay, so okay, so here we have 3 and 5, and here we have it's okay, so 3 and 5 and 9, 3 and 5 and 7, and no, it's like it's 2 and 4, 2 and 4, 3 5 2 4, because in the second test case we have the 2 and 4, 2 4. Okay, so here you don't need to append. Are we gonna yes, you can write the C correct path, you get the point. Yeah, okay. So here we don't need to make the DFS. Okay. I'm just printing the stack P and stack. Okay. So what we're gonna do in this test case? Now we have to search through this and through this. I think I'm gonna make a while loop. So if for okay, so if we find this, we don't for the two. So I think I don't need even this. So while can you join Discord because I think help you on life? Yeah, of course. Of course. So everyone, we have a Discord server. Is in the link of the YouTube channel bio. If you want to join, you're very welcomed. So do join a bit. So could draw. Hey, is good.
Yo, can you hear me?
Hey, how are you? So I think I'm gonna.
So let's say you have these two lists. Now, how are you going to calculate the answer? Just solve this half problem. How are you going to return? Now you have the path for both of them. How are you going to find the lowest common ancestor if you have both of their paths?
I'm gonna make a while loop. If we find, I'm gonna make a while loop for the two of them. If we found like in this, if I found 5, then I'm gonna stop, and here I'm gonna search for 5. If I see if it's 5, then I'm gonna return 5. If it's not, then I'm gonna return its common ancestor.
So one thing you can notice is that the first root is always going to be the same because they're part of the same tree, right?
Yeah.
And then they can go to the left subtree or the right subtree. So you can either start from the start and say at the moment they change the numbers or the list ends, you return that, or you can just keep popping until you find the same number. Does that make sense?
Yeah.
Okay, so you can code it out.
Can you repeat, because I was not really focused?
Okay, so there's 2 ways you can calculate the common
No,
ancestor.
I'm gonna use the pop because we're in a stack. Or are we gonna use a list?
I mean, in Python, stack is sort of a list, so you don't have to worry about it.
So we are using a list, not stack, actually.
Sure, let's think of it as a list. So let's say you go from the start to the end. Things are gonna be similar until they start becoming different, or the list ends, right?
Yeah.
So the moment the list becomes different or it ends, you return the latest common number. Make sense?
The latest common number. So and we're gonna make a variable. We're gonna store in it the common number.
Yeah, common number so far. The moment you find that the list is over or they are not common, you can return the common number so far, and that's going to be your latest common ancestor, correct?
Okay, so while is million of stack Q and GS P, then if okay, so common equals 0. So if stack Q polygon stack q of p. Then we're gonna make comma equal stack q of g. So okay, stack q of g. But if they're not, so if they're not,
you can just break the loop and return the current common elements. If they are the same, you keep updating the common element.
but no, but what I'm supposed to update, the I of or the G? Because in this case, I'm gonna update the I.
You do I plus equal to 1 and j plus equal to 1 both. You're traversing them both, one step at a time.
No, but so like in this case, 5 and 5, then G it's gonna go out of the range.
Yeah. So that's your last 5 is your last answer.
Oh,
It
and
should
yeah,
not-
we're gonna break from the loop. Yeah, okay.
Yeah.
So G plus plus 1, I plus equal 1. Yeah, so now we have the common. Do we run it? So let's just return 1.
Also remember to return common.
Yeah, I returned. So do I have to define it? Okay, so I think not. So int, what is it?
You just need to write I equal to 0 and j equal to 0.
Yeah, I wrote it. Or like or, this or, okay. Okay, has no attribute val. You know what? We don't need this for now. Like
No, put and. The problem is in the DFS thing.
yeah.
Wait.
No, it's not. So stack p print common.
You need and, by the way. You need to stop immediately if one list ends.
Yeah. Where do I place it?
Replace or with and. Oh, it's asking to return a node. Okay. You're returning a value. It has to return like a pointer to the node.
Okay, I'm
So now you have...
I'm just gonna print it, okay?
So can you print the common? Do and print the common so you can see if you got it right.
Like, it's not and. Okay, so.
You have to do and because as soon as the shortest one finishes,
Oh,
you have to get out of the loop.
Yeah. The negative one is not. Okay, so this is correct here.
Now you can try for the stack of the second problem to make sure your problem is working right.
No, but in this. Why this is. Okay, so in this case it's not true.
You need to update your paths, right? You need to have a different stack Q and stack P for this and see if it works right.
Yeah. So now we're gonna deal how to update the queue. Okay.
Just if it works for the second test case, you can work on building the stack.
So do it. I think. Okay, so let's make it. So no, it's not. I'm gonna print. I have to call it. So I don't know what is going on. So the output is.
So you need to think about how are you going to populate the stack P and stack Q. So first thing is clear that you're going to call DFS 2 times, because first to populate stack P, second to populate stack Q, correct?
No, I'm not understanding anything now.
Okay, so you have the stack and you know how to calculate ancestor from the stack, correct? You know how
Maybe,
to
yeah.
calculate the answer from the stack, but now you don't know how to create the stack, right?
Yeah.
Every node will have a different stack because they have a different path, correct?
Yeah.
So P and Q will have different stacks and different paths, correct?
Yeah.
So you need to call the function 2 times and it will return you path of that node, correct?
What function?
Like you need to have a helper function on that your DFS is trying to do. Like you need to have a function that says make stack and do DFS in that. Like, you know.
Oh, so we're gonna make another function. That.
I know, just rename the DFS. Like your DFS is supposed to make stack and return the stack.
Yeah.
That's what it's supposed to do.
No. So in every in the beginning of the DFS, in the beginning of the definition of DFS, we're gonna make a empty stack.
Yeah, you have to pass an empty stack. That's a good idea. Like you have to pass an empty stack and it will populate it with the answer. Does that make sense?
Yeah. Okay. But if I make this at a okay, so
you need to have 3 variables, right?
yeah, okay, but in this what I'm supposed to make as a
so you need to pass a route because that's where you're going to start traversing from, correct? You need to have a target node because you need to reach that node, correct? Like that you're going to pass P or Q to that, correct? Does that make sense?
that's overwhelming, girl.
You're lost?
So we're gonna make another node as a parameter.
So your function, okay, you're gonna give your function
which
your
is
root.
DFS or another function?
It's only one function. Like you just you can name it whatever you want. You can name it DFS or you can name it make stack, whatever you want. But it's only gonna be one function. Okay.
Okay. So we're talking about one function. Okay. So in this we have to make root and then the target node, as you said.
Yeah, exactly.
And the target node will be
P or Q, like whatever you want, like
P or Q. What's the target node? I didn't really understand it.
So basically what your function will do, it's gonna traverse from root to the target node and return its path.
Yeah. So okay. So we're gonna make P and Q as a
target.
We're gonna make them two, like 2 other parameters, which is the P and the Q.
No, there's only gonna be one target, and you're gonna call it once for P and then once for Q. Make sense? It will take root.
Okay.
It will take target. It will take path.
And if we find the target.
Yeah, if you find the target, return that path. And we return path for P, return path for Q. So you call the function 2 times.
Like either you are a genius or I am dumb. So.
No, I'm not able to explain it well. You know, I will.
So here we're gonna pass the not the Q or the target. I'm gonna make it target, okay?
Okay, so do root, target, path. That's
And
gonna be
path,
your.
yeah. And path. Yeah, okay.
Also, remember to put self. I don't know if you're putting self
Where?
in the parameter of DFS, like self, root, target, path.
Yeah. That's okay. So now in the DFS we're gonna make root and then target.
Anytime you write any function, you have to do if not root, return false. That's gonna be your first thing
Yeah.
because you always could get a none, you know.
Okay. And then like you're seeing the stream.
Yeah, you have a slight delay, so I'm seeing it a little later. So I'm just predicting what might be the error. I'm trying to explain it with you. Does that make sense?
Yeah. So in the first root dot left, and then I'm gonna make q. But
So did you do if not root return false?
return false.
Yeah.
Okay, so here is target and here path also.
The first thing you should write is if not root return false.
Yeah, I did it.
Okay. Now, next thing is, how do I explain this?
If you want to share the screen, you can.
So, see, you have to understand the meaning of this function. This function will take root, this function will take target, this function will take an empty list, and it's going to return the path from root to the node, from source to the target. Make sense?
So we're gonna make a condition. If we find the target, then we're gonna stop.
Yeah, if we find the target, we return true immediately, and then the path is going to be our path. So I think the best thing for you to do right now is add in your other function, you should write path to q as an empty list. Can you do that? Path q as an empty list and path to p as an empty list in the main function.
Yeah. Okay. Path p, and then in the DFS I'm gonna make root and then the target.
And then so you call the function first, so you can understand what is the expectations of this.
Yeah, but when we call it, what I'm gonna make as parameter q or p?
Both. You have to
Oh,
call
so
them
we're
twice.
gonna call it twice. Okay.
Yeah.
And
So
here
root is gonna be your root.
path q and here path p. Okay. So and
Just make sure you're doing p for path p and q for path q.
yeah. Oh, okay. And now we
Okay,
have
so
to
you
add the
realize
condition.
So you realize the answer is gonna be in the path q and path p, correct?
Yeah.
So you have to append in the DFS. You have to append path dot append root.
Yeah.
Okay.
Yeah.
And if your current root is the target, that's the best case. You just return true.
Okay, so if root equal target, but we don't have to return true. We have to return the target.
So the path will automatically be in the path variable. So as soon as you return true, the path will have the correct path. Make sense?
Okay.
So part of recursion is that you have to trust that the function will do the right thing and build around it, then make the recursion function.
Yeah, okay. Okay, so what's next?
So if root is target, you return true, right?
Yeah.
And then otherwise, you have to call recursively if root is in like left or root is in right, return true. So like if find path root.left target path or find path root.right target path are true, return true. Make sense?
No, I just I didn't keep up with you.
Okay, so you see how when you do recursion, there's a base case, then a recursion,
Yeah.
correct?
Yeah.
So we covered the base case if our current node is the target and we return true, and that's the path, okay? But if our current node is not the target, then it could either be in the left or in the right,
So
correct?
we're just gonna call it again.
Yeah, call in the left, call in the right.
Yeah. So self.dfs root.left target path.
Yeah, and you have to see if any of them is true, right? It will return something, right? You need to save it.
But any of them is true. It's gonna go back to the initial function.
If any of them is true, they're gonna return you now, then you return true.
So we have to add another condition here.
Just say left is equal to the left recursion, whatever you left value, right value. If any of the values is true, you just return true.
No, I didn't send you really.
What?
I
you
really
didn't understand
didn't stand the condition
Okay.
about the left and the right.
Okay, so you call the left function,
Yeah.
okay? And you save the value of that left function, which is true or false, in a variable called left, okay?
Oh, okay.
So it's gonna be something like left is equal to self.dfs.
Yeah, okay. And then right equal.
You get it?
Okay.
Yeah. And then return left or right.
Oh, one of them is gonna be false. True.
Yeah, one of them gonna be true because we're guaranteed to have that node in the tree.
And that's all.
Wait. What did you say?
That's all. I think this is it.
You need to check if path P and path Q is doing well or not. You need to print path P and path Q. Also, you're using stack P and stack Q, so make sure the naming is fine, but just make sure path P and path Q is correct.
So I'm gonna every time. So what is this path P?
Just print path P and path Q after calling the function.
Do we still have the stack Q and stack P?
No. You have to replace them with path P and path Q. But if it's correct, you can replace them.
But here we have... Okay, so self path equal path. Okay.
At line like 14, print path P.
Okay. Okay, so this is path Q and path P. Okay, so really can't understand the output, but
So the answer is that your function is going to return true or false, but the real answer is going to be in the path variable because you change your path all the time.
yeah.
Oh, okay. Hmm. Hmm. How do I check if path P? Oh, path Q is none. Oh, common is none. Common is none. Oh, can you return common?
Okay. Um,
But common is also none, so there's a problem.
so here the output is null. But no. The third test case is good. Okay, so val left tree node 2, right none. Okay, so
Wait.
like he's in the two test case he's returning null, but in the third he's returning variable actually.
So is path P okay? 1, 2.
Yeah. 1 and the left is 2. Its left is none and
Here?
right is none and the right is none.
Wait, are you populating them well? Can you see if Q is path Q and P is path P
Okay.
in 12 and 13? Line 12 and 13.
Okay, so this is path P and this is path Q. So path Q1 and at its left has 2 and so the first element is 1, 2 and there is nothing right, and then in the right there is nothing, there is 3 element. What do we have? Why do we have 3 element in a node that has 2 element?
No, it will just do nodes left, and on that nodes left, it's
Oh,
really
nodes
difficult to
right, yeah. We're gonna call it twice, yeah. So don't really know why. So
How about you do this in the DFS? If left or right, then return true. Otherwise, you pop. I don't think it will ever reach that, but just to be sure. If left or right, return true. Otherwise, you pop from the path.
okay. Left or right.
So
True. So do you have to make it in?
I think true. Yeah. Okay.
So why you're doing this?
It's
Oh,
because if it does not exist in left or right, that means it's not in this. Like you need to pop it, you know? It's not in this node.
yeah. So the second test case is good, but the first
Oh,
he's outputting 5.
Oh, we didn't return false, no? Maybe we return false in the else statement. We forgot to return false.
Where?
In else, I forgot to say to return false.
After the pop?
Yeah, because we didn't return anything.
Oh yeah, but same thing. Okay.
Okay, so it's populating correctly.
Yeah.
Oh, it's populating correctly. You just from the stack, you just need to find the correct ancestor.
Yeah. So here
Okay.
he's outputting 5, but
Oh, I see.
can we make a condition like if the first element?
So you see
I
the
don't know.
problem? Do you see the problem?
Like he's
See,
outputting 5.
so the problem is that 5 is one of our nodes, correct? So the path is 3 to 5, 3, 5, correct?
Yeah.
And the other node is 1, right?
Yeah.
So the path is 3, 1. So it should be 3.
Should be 3.
If
Yeah.
the node is the ancestor, you cannot include it. That's the problem.
The node is the ancestor.
Like if you're outputting the node, you should return its ancestor because you cannot return the node unless it's root.
Oh yeah. Yeah. Okay. So
I just wish I could see the path P and path Q is correctly made or not because it's so hard to read.
yeah. Can't we just append like dot value their value to see it better?
Yeah, that's a good idea.
But like
Let's do append root.val.
when I type dot val, it's gonna pop an error.
Oh, pop. But pop is just gonna remove from the list.
No.
That's
It's
fine.
gonna no. There is an error where when I type root dot val.
Because it's not. You need to have if not root return false first. Always.
No. Okay. So I'm gonna just change its position. So he's also saying that int object has no value has no attribute value. Okay. It is not an int.
Oh, it's because it's checking. Okay.
Like why is it doing this?
Because if we're checking root equals target, like, right? I think that's the.
Oh, okay.
Wait. I need to think. Why is it int?
But don't we have to check if root.val equal target?
How about you just return root and we just see if the path is correct. In the main function, just return root and let's see if path P and path Q is correct.
Okay. Wait. Okay, so the first test case is good.
It's because the answer for first test case is root.
Oh yeah. Yeah. Man.
But is the path correct?
I don't really know how to read it, man. It's too long.
But we appended the value instead of the root.
I didn't actually.
You need to root.val. You need to path dot append root.val. In 34, line 34.
Oh, okay.
You need to append the value.
So yeah, 35 to 4, and here 35, 31. Yeah, it's all good.
Okay. And the other test cases?
Yeah, they're good actually. Like 3, 5, 2, 4, and 3, 5.
So your path is correct.
Yeah.
So you just need to figure out when you have the path, how you calculate the ancestor. No?
We we did it actually. Or it just has.
How about you print common? Print common and see if you're calculating it correctly every time. The delay in the stream is crazy.
Like it's. So what we're gonna do here?
Just print common to see if you're calculating the common correctly, because the stack, like the list, is perfect.
So in the DFS,
no, in the main function you're calculating common, right? See if that's correct.
Okay, so in the while.
Yeah, in the while loop.
Okay, so
just print common and see if common is fine. Like if it's returning what it should return. If that's fine, then you can just return that node instead of the number.
Okay, so 3, 5. This is good here. No. Okay, so here it's 3, 5.
Remember to print common outside the while loop when you're done with the everything. Like when you're done with calculating common.
Like print what?
Print common outside the while loop when you're done calculating common completely. You keep updating common every time, right? You don't want to print every time. You want to print it only when you've done calculating it, when you're outside the while loop, when your common is ready to return.
Yeah, it's gonna be the last loop, which is 5 here.
Okay. Sorry, there's a delay in stream. Okay, so is it working well for all cases?
No, it's just for the for 1 and 3, but for the 2 it's I think it's breaking the loop when no. I don't know why he's not continuing to print 3, 5, 2, 4. Oh, if path Q equal path G, and so okay. No. There is in this condition there is something we're missing it. So
are we calculating path for the second case correctly?
Yeah.
Okay, so then we cannot calculate well the ancestor from the path lists.
Yeah.
Okay, let me check the second case.
Oh, so checking hint.
No, I'm just checking the case. Like, your stream is a little behind, so I want to see the example case.
Okay.
Like, what is gonna be the path for second? Okay, case 2. P is 5 and Q is 4, correct?
Yeah.
So is the path P just 3 or 3 and 5?
3 and 5.
Okay, it should just be 3. And is the path Q 3, 5, and 2 or 3, 5, 2, 4?
3, 5, 2, 4.
We need to remove the last element, I think.
So it's gonna return. Oh, so he can return 5?
No, we can't return 5, right? Or we can. If we can, then it's fine.
We can. We have to return 5 actually in case 2.
Okay, so you have 3, 5, and 3, 5, 2, 4, right?
Yeah,
So why is common not 5? What is common?
common is 3. No, no, no.
Hmm.
I'm returning root, man. Like, wait a minute. Okay,
But
okay.
you're printing common, right? What's the common?
It's 5. It's 5.
Okay, so now it's fine. You just need to print.
Man. Okay. So he need to. So we need to return a node, and here we're
Yeah,
returning a comment.
yeah.
Okay.
I mean, the path had numbers before. You just need to have nodes now.
Yeah. So how we're gonna make the common a node?
So instead of path qi, you should just have path qi dot val. That's the only difference.
No. Oh, okay. The output is good, so I'm just gonna return common and here root, not root dot val. Okay.
And let's pray.
So let's see.
Did it work?
Well, it's submitting.
Okay.
I think we're good.
Eh,
Yeah, we're good. No. Oh,
no?
it's like test
Okay,
case
it must be
29 of 32. Like,
none. If it's none, you should return none, right? What's the test case?
the test case, it's. Uh, I don't know how to visualize the node. So
3?
P equal 9998 and Q equal 9999.
Okay, wait. Wow, that's a long. Oh, 998 and 999. And what's the time limit exceeded? Time limit exceeded. Okay. It's not an actual problem. It's that it's
Oh,
taking
it's
a little.
just time limit. I
Yeah.
thought. Oh, okay. So the time complexity is like it's for the time complexity. Like
Yeah,
we're not in
but
the
it works.
oh, okay. So
So now, how do I make this faster?
no, no.
Why?
Okay, we
What's
cannot
wrong?
start from
You
the
made it
beginning,
work.
man.
You need to think of different things, you know?
Yeah. Or ask ChatGPT.
You have to calculate path on the fly. That's the problem, I think. Yeah, sure. You can ask ChatGPT. I will leave the call so I can follow your stream, okay?
Okay, yeah.
Like,
Hey, nothing. I'm gonna send you a message later. Okay.
were you saying something?
Not now. Like, I'm
Okay.
gonna talk to you later. Okay.
Okay.
Okay. Thank you. Mm, so, it was our friend. Like, it's she's very genius, man. Just gonna ask Chat GPT to make the so to make the things faster. Okay, so the code is running good and all the test cases are submitted, but to screen. So the okay. So optimize issue. We need to focus on the reducing the efficiencies caused by intervention with 3 multiple time. Current implementation for that one. So optimize approach. Okay. So closed common ancestor. Okay, so 4 lines. Oh, I want my approach. I'm gonna stick to my approach. Okay. So so for if okay, else break. Okay, you cannot. So what are the major changes? His return here, find path. So path dot end of root equal. He didn't. Okay, so he's not using a recursive function. He's looping it. So there is, or he is. Oh, he is. So the find path. Okay. So let's see it. That's not it. That's not it. Okay. Hey, welcome stream, man. Okay, so actually the solution was so good, but there is only one problem with the runtime. So I think it was a good stream. I think we're gonna end our stream here. We're gonna end our video. Thank you everyone. The stream is too long. I'm gonna divide it into 2 parts, into 2 video. So this is the end of stream. Thank you everyone for watching. Thank you everyone for following. We are currently above 500 follower. It's really good milestone for me, for the channel. I hope that I'm not only the one benefiting from the channel. I hope you are too grinding, and I hope the channel motivates you to grind more. And as usual, tomorrow we're gonna stream every day a new video. So see you tomorrow. Good night.